Hello and welcome to this video that covers the prime factorisation worksheet. So for question 1 it says list all the prime numbers below 25. This one should be a relatively straightforward question. We just say that, well, the first prime number is 2, 3, 5, 7, 11, 13, 17, 19 and 23. All the prime numbers that are below 25, every other number is not a prime number. So this one hopefully should have been relatively straightforward. For question 2, express 44 as a product of its prime factors. So we put 44. We can split it up in any number of ways. In this case, I am going to go for 11 and 4. So 11 we know is a prime number as we've just expressed it as a prime number here. And then the next step we have is 4, which is split up into 2 and 2, because these are a pair of factors that equal to 4. And therefore we have reached the end of the branches, end of the tree, where they are all prime numbers. So we can say, well, 44 is equal to, let me reduce the pen a bit, is equal to 11 times 2 times 2, which is equal to 11 times 2 squared. And that is 44 as a product of its prime factors. Let's look at the next one, which is 84. So 84, we can plug in, and 84 as a result. The first step I'm going to do is pick two factors of 84. So in this one I'm going to do 4 and 21. And then we go through and we split 4, so 4 is going to be split up into 2 and 2. So these are both prime numbers. And then we've got 21, which is, let's put it in the same pen, 21, which has the 7 and 3 as prime numbers. And these are factors of 21, so we can highlight these as our numbers. So we can say, well, 84 is equal to 2 times 2 times 7 times 3, which is equal to 2 squared times 3 times 7 as a result. Let's have a look at the next one then, which is 109 for question number 4. So we've got 109, and what can we do for this one? Well, 109, if you've gone through the calculator, you will determine that there are no possible values for this. So 109 over 2 doesn't work, 109 over 3 doesn't work, 109 over 5 doesn't work, etc, etc, etc. So here we can say, well, the product of its prime factors are simply 1 times 109, because 109 itself is a prime factor, which is obviously equal to 109. So for this one, this is a prime number anyway, so its prime factors are simply itself and 1. Let's have a look at number 5. Number 5 is 450. So 450 as a product. So in this one, it's 450. And let's divide through by 10 as a starting point. So we'll do 10 and 45. We can then split 10 up into 5 and 2, which are both prime numbers. And then we can have a look at 45. We split 45 up into its prime factors. We have 9 and 5 we could use. But 9 is not a prime number, but it can be made up from 3 and 3, which are both prime numbers. So here our result is 3 times 3 times 5 times 5 times 2. So 450 is equal to 3 times 3 times 5 times 5 times 2, which is equal to 5 squared times 3 squared times 2. Note that you can do this way any way you would like. This is just the way that I have done it. As long as you get the same results and as long as mathematically it makes sense, it is perfectly fine to do another way. Okay, the next one is 1008. Now 1008 is a really big number. They're not necessarily easy from first go. The way that I would treat this one is first divided by 2. So 1008 divided by 2 gives you 2 and 504. And 504 is still a big number, so we can split this again into 2 and 252. 252 is a relatively big number, so let's split it up again to 126 and 2. Then we still have 126 is relatively big, not sure on that one, so we could say, well, 63 and 2 is the answer. Now 63 is not a prime number because 9 and 7, 9 times 7 is 63, so 9 and 7 go in, and then 9 can be split up into 3 and 3. This is where it's good to be very proficient in your times tables because you can easily see whether a number or not is a prime number. 63 you might think is a prime number, but if you are confident in your times tables, you should quickly see that that is not the case and that it is not a prime number. So we can see that the prime numbers here, 3, 3, 7, and then we've got 2, 2, 2, and 2. So if we were going to write the result for this one, 1008 is equal to 2 times 2 times 2 times 2, which is 1, 2, 3, 4 2s, 1, 7, and 2 3s. Oops. Times 3, and we can say, well, that's the same as 2 to the power of 4 times 3 squared times 7 as a result. Okay, now for a question that might be a little bit harder than GCSE, certainly in the higher levels, is express 60 squared as a product of its prime factors. So to deal with these types of questions, the first thing you should do is you should just find the product of 60, express 60 as a product of its prime factors. So let's have a look at 60. So 60 can be split up into 6 and 10, with 6 going into 3 and 2, and 10 going into 5 and 2. So 60 is 2 times 5 times 3 times 2, which is equal to 2 squared times 5 times 3. Now, what we were after in the question is 60 squared. So what we can do is we can take all of these individual terms and square it, because we squared the left-hand side. You can treat it as an equation. You've squared this side, so you need to square all the components on the other side. So we could say, well, that's the same as 2 squared squared times 5 squared times 3 squared. And that will give you your result. If you wanted to do 60 cubed, instead you could do 2 squared cubed times 5 cubed times 3 cubed. So all we do first is find what the prime factors are of the original number, in this case 60, and then look to see if there is any power. We can square, cubed, or to power 4, 5, etc, etc. So in this example, we want 60 squared, so we say, well, 60 squared is the same as 2 squared to the power of 2 times 5 squared times 3 squared, which we can simplify one here as 2 to the power of 4 times 5 squared times 3 squared. And that's your result for question 7. Let's have a look at question number 8. Question 8, express 100 as a product of its prime factors. So here 100 we can split up into 10 times 10, so 10 and 10, which gives 5 and 2, and 5 and 2. So the result of 100 is 5 times 2 times 5 times 2, which is equal to 5 squared times 2 squared. What about part B? Express 196 as a product of its prime numbers. So 196 split up. Well, here we can say, well, this is the same as 2 and 98. If we split 98 up, we can say, well, 2 and 49. And 49 can be split up into 7 and 7. So we end up with the result of 7 times 7 times 2 times 2, which is equal to 7 squared times 2 squared. And finally, we have, oh no, well, not finally, but part C, we have 25 as a product of its prime factors. So 25, you should hopefully know that this splits into 5 and 5. So therefore, it's made up of 5 squared. So part D says each of the above numbers is a square number. How can we tell this from its prime factors? Well, if you look at the prime factors, you'll notice that all of them are squared. 25 is 5 squared. In 196, it's 7 squared times 2 squared. And in part A, it's 400, it's 5 squared times 2 squared. So the answer for this one is that each of the prime factors are squared. And that's how you can tell whether a number is a square number, because its prime factors will all be squared. Anyway, thank you for listening. That is the end of this worksheet. If you have any questions, then please let me know.